All right, this is section 5.1. We're talking about quadratic functions. So let's look at the characteristics of quadratic functions. So the graph of a quadratic function is a U-shaped curve, and we call that curve a parabola. So you can call quadratic functions a parabola. So one important characteristic of a parabola is that it has an extreme point, either a max or a min, and we call it the vertex. So I have one right here. There's a vertex. So if the parabola opens up, like it does here, it's opening upward, then the vertex represents the lowest point on the graph, and we call it the minimum value for the function. So at this vertex here, you notice that this point right there is the absolute lowest point within this function right here. Now, if the parabola opens downward, say like this, then our vertex would be right here. And we would have, this would be the highest point on the graph, and we would call it the maximum value. Because within this graph right here, that is the highest point. And notice for the parabola that's opening downward, you don't have a lowest point because your arrows keep going down. And also for the parabola that opens upward, it doesn't have a highest point because your parabola keeps going upward. Now you can also call the vertex the turning point in the graph. Okay, now let's look at something called the axis of symmetry. Okay, so if I have a line that goes right through the vertex, either here or right here, got a line that goes right through the vertex, and a vertical line. That line right there is going to cut that function in half, and they're going to be mirror images on either side. Okay, so that line would be called the axis of symmetry. Okay, now let's look at some forms of quadratic functions. So we said that a quadratic function is a parabola. A quadratic function is a polynomial function of degree 2. So say we have something like 5x squared minus 3x plus 1. Okay, well, we have x raised to 2 here, x raised to an understood 1, and a constant is always x raised to 0, because anything raised to 0 is really just 1. Okay, so the highest degree here would be 2, so it's a degree 2 polynomial. Now we have two types of forms. We've got a general form. So that would be f of x is equal to ax squared plus bx plus c, where a, b, c are real numbers, and a is not equal to 0. So let's say that a was equal to 0, and we'll see what happens. So 0x squared plus bx plus c. Well, this entire term here would go to 0, and then we would have bx plus c. So this graph, since x is raised to 1, wouldn't be quadratic anymore. It would be a linear function. So that's why they say that a cannot be equal to 0, because if it is, then you lose the x squared, which gives your function the quadratic characteristic of that function. Okay, now let's look at the other form, standard form. So f of x is equal to a times this whole thing, x minus h, the whole thing squared, plus k, where again a is not equal to 0. So let's look at the case where it is equal to 0 and see what happens. Okay, so 0 times x minus h squared plus k. Okay, so this whole thing would go to 0, which means it would be equal to k. K is just a constant, so we wouldn't have a quadratic function anymore. We would just have a constant. Okay, now within your standard form, you are able to find the vertex, and that is defined as hk. So whatever this number is here, and whatever this number is here, that will be your vertex hk. Now, if you're in general form, what you'll need to use is these functions right here. So h is equal to negative b over 2a, and then k is equal to whatever you found for h, plug that back into the quadratic function that they gave you, and that's going to give you k. That's essentially what this is saying right here. Because you notice here's your function, and you're plugging in h into your function. H is equal to negative b over 2a. Here's your function, and they're plugging in negative b over 2a, which is h, so they're essentially saying the same thing. So let's look at this question here. Consider the function f of x is equal to 2x squared minus 6x plus 7. Find the vertex and the line of symmetry of f of x. Okay, so we notice that it's in general form, so I have to use these functions right here. So h, well, let's go ahead and find a, b, and c first. A value is 2, b value is negative 6, and c value, even though we don't need it, we'll go ahead and find it. It's 7. So h is negative b over 2a. So negative, and b is negative 6. Okay, 2 times a is 2. So positive or negative times a negative gives me positive, so 6 over 4. I can take a 2 out of both of those, so it'll be 3 over 2. Okay, so h is 3 over 2. To find k, all I'm going to do is plug in what I know for h into my function. So 3 over 2. So this will be 2 times 3 over 2 squared minus 6 times 3 over 2 plus 7. So this will be 2 times 9 over 4 minus, cancel 2 here, and here I'm left with a 3. 3 times 3 is 9 plus 7. Cancel a 2 here, and here I'm left with a 2. So 9 over 2 minus 9 plus 7, so 2. Put that over 1. Need to multiply by 2 over 2 to get the denominators the same. Okay, so I'll just come over here. 9 over 2 minus 4 over 2. 9 minus 4 is 5 over 2. Okay, so our vertex is hk, so that means it is 3 over 2, comma, 5 over 2. So that's one of our answers. And then we need to find the line or the axis of symmetry. It means the same thing. Now when we were over here, we said that the axis of symmetry goes right through the vertex. Okay, so it goes right through the vertex here. We know that the vertex is hk. Okay, and what we have here is a vertical line. We know the equation for a vertical line is x is equal to some number. Okay, well, let's go back to the vertex. The value in the x coordinate, because remember you can write ordered pairs as x, y. The value in the x coordinate spot is h. Okay, so x is equal to h. That's going to be the equation for the axis of symmetry or the line of symmetry. So coming back over here, we said that h was equal to 3 over 2. So that means that our line of symmetry, so line of symmetry is equal to x is equal to 3 over 2. And those will be our two answers. Now looking at the graph of this function right here, notice the graph is opening upwards. Okay, so here's our vertex, and it would have the ordered pair 3 over 2, comma, 5 over 2. If you pull that down right here, yeah, that's halfway between 1 and 2 because 3 over 2 is 1.5. And then 5 over 2 is 2.5. Go to the y value, it's between 2 and 3. Okay, so there's our vertex. And then the line of symmetry should go right through the middle of this thing. So that should be x is equal to, and then notice it goes right between 1 and 2 there. So that should be 3 over 2, which is our h value. Now to figure out if it's going up or down, so in this case we have a minimum. So our vertex would be the minimum. If we didn't have the graph, all we need to look at is the leading coefficient right in front of the x squared. If it's a positive, it's going to be a parabola that opens upward. If it's a negative, then it's going to be a parabola that opens downward. Notice that we have a positive 2, so this graph will open upward. So that means that we would have a minimum for our vertex. So let's look at this one. We're doing the same thing. Given a function, find the vertex, find the line of symmetry. This function is given in general form. So I need to find A, B, and C. So the number right in front of x squared, we don't have one, so it's understood to be 1. 2, and then negative 3. So h is negative b over 2a. So negative 2 over 2 times 1. So negative 2 over 2, or negative 1 for h. Now to find k, I just take what I found for h and I plug it back into my original function. So 1 squared plus 2 times, sorry, that's negative 1. Negative 1 minus 3. Negative 1 times negative 1 is 1 minus 2 minus 3, so 1 minus 5, or negative 4. Okay, so our vertex is negative 1, negative 4. And then our line of symmetry is going to be x is equal to whatever h is, which is negative 1. Now if we are just looking at the function, should the function open upwards or should it open downwards? Well, looking at the number right in front of x squared, that is a positive 1, so it should be opening upwards, which means our vertex should be a minimum. Okay, so here's the graph of that function. Notice our vertex is right here, and that's at negative 1, negative 4, negative 1, negative 4. The line that goes right in the middle, right there, and that's x is equal to negative 1. Notice that our vertex, notice that the parabola opens upward, so that means our vertex is indeed a minimum value. Okay, let's look at this one. Now notice we're not in general form anymore. We are in now standard form. It looks like this right here. Okay, so that is actually easier to find the vertex and the line of symmetry, because you've got f of x is equal to a x minus h squared plus k. So whatever this value is here, that's your h. Whatever this value is here, that's your k. Just make sure you have a negative right there, which, okay, we do. So that means that h is 3 and k is the negative 8. So that means our vertex is going to be 3, negative 8. And our line of symmetry is going to be x is equal to 3. Okay, so now let's look at the graph of this function. Okay, notice here's our vertex right there. So 3, negative 8, that's what we found for our vertex. The line that goes straight through it, or the line of symmetry, the axis of symmetry that goes through the vertex. Yes, that, oops, sorry. Got those backwards. 3, comma, negative 8. So the line of symmetry is x is equal to 3. Now notice that this parabola opens upward, and how you can tell it's going to open upward in this type of form, you look at this value right here. If it's positive, it will go upwards. If it's negative, it will go downward. So since it's positive 4, we have a parabola going upwards, which means our vertex is going to be a minimum.